Ever get that feeling like AI's getting smarter every single day?
Oh, yeah.
But like how it's actually happening is kind of a mystery.
Right.
Today, we're going to peel back the layers on something called reasoning language models,
Okay.
or RLMs for short.
RLMs.
Think of them like the super smart like cousins of those chatbots you've probably messed around with.
Yeah.
And you've sent us a whole bunch of research on this,
Yeah.
including parts of a paper called Reasoning Language Models, a Blueprint.
Okay.
And honestly, I think you're going to be pretty amazed by what we uncover today.
Yeah, definitely.
We're going to try to figure out how these RLMs actually think
Mm-hmm.
and what makes them so different from the kind of AI we're all used to.
Right.
Plus, we'll explore how this tech could become something that like anyone can use.
Yeah.
Not just something that's locked away, in these big tech companies.
Mm-hmm.
What do you think?
I think that's really important.
Pretty exciting stuff, right?
Yeah, it really is. You know how ChatGPT kind of took the world by storm?
For sure.
Well, RLMs have that same, game-changing potential.
Wow.
They aren't just spitting out text, they're actually reasoning.
Oh, wow.
They're understanding context
Okay.
and even making decisions.
That's incredible.
It is.
I mean, the source material calls them a transformative breakthrough.
Yeah, and they're right.
And I'm really curious to know, what makes them so different
Yeah.
from those large language models,
Mm-hmm.
the LLMs
LLMs.
that we hear about all the time.
Yeah, good question.
What's the main difference?
So imagine this.
Okay.
LLMs like GPT-4,
Mm-hmm.
they're incredible at understanding and generating human language.
Okay.
So they have this massive library of knowledge just in their heads,
Right.
but they aren't really thinking things through
Okay.
strategically.
So it's not.
They're more like that gut feeling you get, fast, but not always super deep,
I see.
RLMs, on the other hand,
Okay.
they're actually designed to be more like that part of your brain that plans
Okay.
and solves puzzles.
Yeah.
They break down complex problems step by step.
Wow.
It's this combination of large language models,
Okay.
reinforcement learning,
Mm-hmm.
and powerful computing
Got it.
that makes them so unique.
So it's not just
Yeah.
predicting the next word in a sentence.
That
It's thinking about the whole
Talking about the entire
problem like we would.
Exactly.
Wow.
And that actually brings up something really important that the research mentions, the potential gap between rich AI and poor AI.
That sounds kind of ominous.
It is a little bit.
What's that all about?
Well, right now, creating the most advanced RLMs,
Yeah.
it's super expensive.
Yeah, I can imagine.
We're talking about companies like OpenAI with tons of resources.
Right.
And they tend to keep their advancements secret,
Oh, wow.
which means smaller companies and researchers, they kind of get left behind.
I see.
And it really stifles innovation,
So it's like this amazing tool is kind of locked away,
Mhm.
and only a select few get to use it.
That's the problem.
Wow.
And the source material really highlights this need
Go ahead.
to make this knowledge and tech open to everyone.
Yeah, I think that's a great idea.
Right. So that way more developers and researchers can contribute,
Mhm.
and we all benefit from a more diverse
Yeah.
and innovative AI landscape.
That makes a lot of sense.
Don't you think that's a much better approach?
Absolutely.
Yeah.
Okay, so let's get into how these RLMs are actually built.
Okay.
I mean, we know there's 3 key pieces.
Right.
LLMs,
Mhm.
reinforcement learning,
Yeah.
and high-performance computing.
High performance computing.
What does each one actually do?
Okay, so think of the LLMs as the foundation.
Right.
They're what give RLMs the ability to understand and generate language,
Okay,
the raw ingredients for reasoning.
got it.
Then you have reinforcement learning,
Yeah.
which brings in the learning aspect.
Correct.
It's similar to how AlphaZero got so good at chess,
Right.
it learns from its mistakes.
So the LLMs give it the knowledge,
Exactly.
and reinforcement learning helps the RLM figure out how to use that knowledge.
Yes.
Okay.
And all of this requires a ton of computing power.
Right.
That's where high performance computing,
Mm-hmm.
or HPC,
HPC.
comes in.
Got it.
It's the engine
Right.
driving the whole process.
I see.
It's actually pretty fascinating
Yeah.
how HPC is evolving beyond Moore's law,
Moore's law.
which is something even the source material touches on.
Moore's law. Refresh my memory on that one.
Okay, so Moore's law,
Yeah.
it's the idea that the number of transistors on a microchip
Okay.
doubles roughly every 2 years, making computers faster
Right.
and more powerful.
Yeah.
But we're reaching the limits
Oh, wow.
of how small we can make transistors.
So we're kind of hitting a wall.
Yeah, we are.
Wow.
So we're finding new ways to increase computing power and like using more processors working in parallel.
That makes sense.
Yeah.
So we have the knowledge base,
Mm-hmm.
we have the learning method,
Yes.
and we have the powerful engine.
Right.
But how do they actually combine
Yeah. How does it all come together?
to form an RLM?
Good question.
The source material keeps mentioning this RLM blueprint.
Yes.
What is that exactly?
It's like a recipe
Okay.
for building RLMs.
I like that.
It lays out all the essential components and the processes involved,
Okay.
starting with the architecture itself.
Okay.
The RLM architecture
Yeah.
is divided into 3 main pipelines:
Pipeline.
inference
As well.
training and data generation.
Data generation. Okay, let's pause right there for a second. Can you walk me through those pipelines?
Yeah.
One by one, so we're all on the same page.
Absolutely.
Okay.
So the inference pipeline,
Okay.
that's where the RLM interacts with the user. It
Right.
takes what the user asks and uses the models that were trained
Okay.
during the training pipeline
Yeah.
to generate a response.
Okay, so it's the part that's actually doing something.
Yeah, you got it.
Okay, got it.
So
So then what happens during the training pipeline?
this is where the real learning magic happens.
Oh, okay.
It uses the data
That-
from the data generation pipeline to refine the RLM's models.
So it's like teaching it
Think of it like teaching the RLM to think more effectively.
to think better.
Yeah, based on its experience. It's
All
a
right.
constant learning process.
Got it.
And finally,
Okay.
the data generation pipeline,
Yeah.
it creates new data
Okay.
to train the RLM.
I see.
It's similar to how AlphaZero played against itself to get better. The RLM essentially practices and generates data
Okay.
that helps it to like refine its reasoning skills.
That's pretty clever.
Yeah. Yeah.
Okay, so we have these 3 pipelines.
Yes.
They're all working together,
Working together.
but what's actually happening inside them?
That's the real question, right?
Yeah.
Like how does it all work?
Exactly.
The blueprint keeps mentioning a reasoning scheme.
Right.
What is that all about?
So this is where it gets really interesting.
Okay, yeah.
The reasoning scheme.
Yeah.
It's like the brain of the RLM.
Ooh, okay.
It defines how the RLM organizes its thinking
Okay.
and how it goes about solving problems.
Makes sense.
It's all about structure and strategy.
Okay, so give me the details.
All right, so part of the reasoning scheme
Mm-hmm.
is something called the reasoning structure.
Reasoning structure.
It outlines how individual reasoning steps are connected,
Okay.
kind of like a roadmap for thinking.
Like a map?
Okay, I like where this is going.
Okay, good.
What are some like examples of these reasoning structures?
Well, they come in a few different forms.
Okay,
Chains,
chains. Okay,
trees,
trees.
and graphs. Okay.
Chains represent like a simple
Oh,
step-by-step flow of reasoning.
Like a straight line.
Yeah, exactly.
Okay.
Trees are more like branching out
Okay.
and exploring different options at each step.
So more possibilities.
More possibilities.
Okay.
And then graphs allow for even more complex connections between steps,
Wow.
making the RLM even more flexible.
Okay, so I'm already starting to picture this in my head.
Okay, good.
The structure
Yes.
sets the layout.
Right.
But how does the RLM actually like move through it?
Yeah, that's a great question.
You know, I think there was also something about like a reasoning strategy
Yes.
in the blueprint too, right?
You've got a great memory.
Uh-huh.
The reasoning strategy guides how the structure evolves
Okay.
and how the RLM decides which path to explore.
A common one is called Monte Carlo tree search,
Monte Carlo tree search,
or MCTS.
MCTS.
Okay.
It helps the RLM try out different reasoning paths
Okay.
while focusing on the most promising ones,
Got it.
just like you might do when you're solving a maze.
Ah, okay. So it's like having a built-in strategy
Exactly.
for problem solving.
MCTS helps the RLM
Okay.
make smart choices
Okay.
about where to focus its efforts,
Got it.
making the whole reasoning process much more efficient.
That's really cool.
Yeah.
Do you have any other questions
Uh,
about the reasoning scheme so far?
No, I think I'm following along pretty well.
Okay, good. Me too.
Oh.
But now I'm wondering,
Yeah.
what are these operators
Yes.
that keep popping up?
Operators, don't worry, they aren't performing surgery or anything.
Okay, good. Uh-huh.
Operators are basically actions
Okay.
the RLM can perform
Okay.
on its reasoning structure.
Mm-hmm.
Think of them like tools.
For like manipulating and refining the thinking process.
So what kinds of things can these operators do?
They can add new reasoning steps.
Okay.
They can change existing ones.
Okay.
Move between steps.
Got it.
And even judge how good a particular reasoning path is.
So it's like they have their own
It's like internal
toolkit for thinking.
Yeah, for thinking.
Wow, that's amazing.
Yeah.
What else can they do?
Well, there are all sorts of operators,
Okay.
each with like a specific job.
Okay.
The generate operator creates new steps,
Okay.
while the refine operator makes existing steps clearer and more accurate.
Wow, this is all starting to make sense.
Good.
But I feel like we're missing a piece of the puzzle still.
Oh, okay, what's that?
How does the RLM, decide which operators to use
Yeah,
and when?
right. How does it learn?
How does it learn and get better over time?
You're asking all the right questions.
Right.
And that's exactly where models
Right.
and training paradigms come in. Okay.
Which we'll cover when we come back.
Right.
They're how we evaluate
Okay.
how well the RLM is reasoning
Mm-hmm.
and teach it to make better decisions.
This is already blowing my mind.
I know, right?
Stay tuned, everyone, because we're just getting started.
We'll be right back.
We'll be back in a flash to unravel the mysteries of models and training paradigms.
Yeah.
Welcome back.
Back again.
I'm still processing everything we talked about in the last segment.
I know, right? It's a lot.
The pipelines.
Yeah.
The reasoning scheme.
Mm-hmm.
Those little operators running around.
Those operators.
It's amazing.
It's like we're getting this glimpse inside
Yeah.
the inner workings of a mind.
Totally.
That's pretty cool.
But before the break,
Yeah.
you mentioned something called models
Yes.
and training paradigms.
Right.
I have a feeling those are
Yeah.
pretty important pieces of the puzzle, too.
Absolutely.
So what are they all about?
They're essential for teaching the RLM
Okay.
how to reason effectively
Mm-hmm.
and make smart choices.
Okay.
Think of models as the brains behind the operators.
So like mini brains inside the bigger RLM brain.
Kind of, yeah.
Okay.
They're usually neural networks.
Okay.
Similar to what powers those LLMs we talked about earlier.
Right.
They learn from data
Okay.
and help guide the RLM's reasoning.
Give me an example.
Right.
Like what kind of thinking do these models do?
Okay, so one type is a value model.
Value model. Okay.
It estimates how good a particular reasoning step is,
Mm-hmm.
kind of like a judge scoring a performance.
I like that.
And then another type is a policy model,
Policy model. Okay.
which helps decide what action to take next,
Okay.
like choosing the best route on a map.
Got it. So there's different types of models
Yeah, different types
doing different things.
doing different things.
Okay. I'm starting to see how this all fits together. But how do these models actually learn?
Right.
You mentioned training paradigms.
Yes.
What are those all about? They're the methods
Okay.
we use to teach the models
Okay.
to train them to make good decisions.
Got it.
It's like coaching them
Yeah,
to become expert thinkers.
like personal trainers for AI.
Yeah, exactly.
What are some of these training methods?
Okay, so one common approach
Okay.
is called supervised fine-tuning.
Supervised fine-tuning.
We feed the model tons of examples
Mm.
of good and bad reasoning,
Okay.
along with feedback
Yeah.
on why they're good or bad.
Got it.
It's like giving them a textbook and a teacher to guide them.
So they're learning from examples?
Yeah, from examples.
Okay.
Another method is reinforcement learning,
Reinforcement learning.
where the RLM actually learns
Okay.
through trial and error,
Trial and error.
getting feedback on its performance,
Right.
and adjusting its strategies.
Okay.
It's like learning to ride a bike.
Okay.
You fall a few times,
Right.
but eventually you figure it out.
It gets better.
Exactly.
It's amazing to see how much research goes into making these RLM
Right.
so sophisticated.
It's really fascinating.
But I'm curious
Yeah.
about how this all translates
Oh.
into real-world tools.
Right.
You know, the blueprint mentions
Yeah.
this specific framework called A1.
Yes. A1. What's
Yeah.
that all about?
A1 is like a toolkit
Okay.
for building RLMs.
Mm-hmm.
It's designed to be adaptable
Okay.
and efficient,
Got it.
allowing developers to create RLM
Okay.
that are tailored for specific tasks.
So Bio1 is like a set of blueprints
It is.
within the bigger blueprint.
You got it.
Okay.
It takes those high-level concepts we've been talking about
Yeah.
and puts them into a practical framework.
I like that.
So,
So what are some of the standout features of Bio1?
okay, so one key aspect is how it handles
Okay.
value and policy models.
Okay.
Instead of having one massive model
Mm-hmm.
doing everything I want, separates them
Okay.
into dedicated server.
Dedicated. It's like having specialized teams
Okay.
working on different aspects of reasoning.
So division of labor,
Division of labor.
even in the world of AI.
Exactly. And this decoupling
Okay.
makes the whole system more efficient and scalable.
Scalable
Meaning it can handle more complex tasks
Okay.
and larger amounts of data.
That makes sense.
Yeah.
But we're talking about like calculations.
Yes, a lot of data crunching.
And data crunching.
How
does By1 handle all of that?
That's a good question.
All the challenges of running these complex systems.
So I1 incorporates some smart techniques
Okay.
to make it efficient and scalable.
Okay. Like what?
For example, it uses batch processing.
Batch processing. Okay.
Allowing the policy server to handle multiple requests simultaneously.
So at the same time.
At the same time.
Got it.
Kind of like a chef cooking multiple dishes at once.
Okay.
It also uses quantization. Which is a fancy way of saying it shrinks the size of the models.
Okay.
Without sacrificing too much accuracy.
So it makes it smaller.
Makes it smaller.
But it still works.
Okay. And KV caching.
KV caching.
Which stores frequently used data for quick access.
So it's like keeping your...
Like keeping your most used tools within arm's reach.
I like that.
Yeah.
It sounds like they've thought of everything.
They really have. And they even considered the challenges of running By1 in the cloud.
Yeah.
Which is how most AI systems are deployed these days.
I remember the source material.
Yeah.
Mentioned the limitations of Moore's Law.
Right.
And the need for like new approaches to high performance computing.
So does EPU1 address those issues? Yeah. Absolutely.
Okay.
EPU1 is designed to leverage those new approaches.
Okay.
It allows for distributed computation. Meaning it can spread the workload across multiple processors or even multiple computers working together.
So it's like, instead of relying on one super powerful computer, By1 can kind of harness the power of many computers working together.
Precisely.
That's really cool.
And this is crucial for democratizing access to RLMs.
Right, because not everyone has a supercomputer in their basement.
By using cloud computing and these efficient scaling techniques, By1 makes it possible for more people to experiment with and build RLMs without needing access to a supercomputer.
That's a huge step.
It is.
Towards making this technology accessible
to
like a much wider range of people.
It's all about empowering more researchers and developers to contribute to this exciting field.
I love that.
Yeah.
This is all incredibly promising.
It is.
But I also want to understand the challenges.
Of course.
And limitations of RLMs.
Right, because nothing's perfect.
Yeah, exactly. The source material mentions some of these. In this section on unveiling the inner workings, what are some of the key insights there?
Okay, so one fascinating aspect is something called token probability analysis.
Token probability analysis.
It's like looking at the RLM's thought process under a microscope.
Ooh, I like that.
So we analyze the probabilities assigned to different words or tokens during reasoning.
So instead of just seeing like the final output, we can actually see the RLM weighing different options.
Exactly.
That's really cool.
These probabilities reveal a lot about the RLM's level of confidence in each step.
Can you give me an example? Like, what do these probability distributions look like?
Okay, so imagine a situation where the RLM is trying to decide between two words.
Two words. Okay.
If one word has a much higher probability than the other, it suggests the RLM is pretty confident in that choice.
Okay.
But if both words have similar probabilities, it might mean the RLM is uncertain.
Okay.
And needs more information to decide.
So it's like seeing the RLM hesitate. Or second guess itself.
Exactly.
That's really interesting.
And this insight can be incredibly valuable for both developers and users of RLMs. Developers can identify areas where the model might be struggling or needs more context. And users can get a sense of like how sure the RLM is about its outputs, which can help them interpret the results more effectively.
That's super helpful.
It is.
But probabilities alone don't tell the whole story, right?
You're right.
I remember something about uncertainty metrics, too.
Yes. Uncertainty metrics.
Of those.
They give us a more precise way to measure how confident the RLM is in its reasoning.
Got it.
They kind of complement those probability distributions by quantifying the level of uncertainty.
Okay, quantify meaning they give us numbers.
Yeah.
We can actually measure and compare.
Exactly.
Okay.
These metrics provide a more objective way
Got it.
to assess how certain or uncertain the RLM is about its choices.
Can you give me some examples of these metrics? I'm all about
You are.
concrete examples. Haha.
One common metric is variance.
Variance.
It measures how spread out the probabilities are.
Okay.
A high variance means the RLM is considering a lot of different options and is less certain about the best choice.
So low variance means high confidence.
Exactly.
Okay.
Another important metric is entropy.
Entropy.
It tells us like the overall level of uncertainty or unpredictability in the probability distribution.
So higher entropy means more uncertainty.
You nailed it.
Right.
There's also verentropy.
Verentropy?
Which measures how entropy changes over time, giving us insights into how the RLM's certainty fluctuates during the reasoning process.
So it's like we're getting this real-time view of the RLM's thought process.
Exactly.
Seeing how it weighs different options, makes decisions, and even like experiences uncertainty.
It's pretty amazing.
Yeah.
And this ability to look inside RLM's brain is crucial for understanding its behavior, identifying areas for improvement, and ultimately building more reliable and robust AI systems.
So we've covered the by one framework.
Yes.
We delved into these probability distributions and uncertainty metrics. It's been a lot to take in.
We've covered a lot of ground.
But I have a feeling there's still so much more to explore.
There is.
What are some of the most exciting areas of research and development in the world of RLMs?
Well, for one, researchers are working on incorporating external knowledge sources into RLMs.
External knowledge source.
Imagine an RLM that can not only access its internal knowledge, but also tap into databases, websites. Wow. And real-time data from the world around us.
So it's not just limited to what it's been trained on.
Exactly.
Wow, that would be a game changer.
It would be like giving RLMs access to the entire internet.
Wow.
It would open up incredible possibilities.
I can imagine.
For problem solving, decision making, and even creativity.
That's amazing.
Another exciting area is the development of more sophisticated value and reward models.
Right, those models that help guide the RLM's learning process.
Exactly.
So it's like giving RLMs even better teachers and coaches.
That's a great analogy.
That's right.
These advancements will help RLMs learn more efficiently and solve even more complex problems.
This is all so exciting.
It is.
It feels like we're just scratching the surface of what's possible with RLMs.
I agree.
What do you think the future holds?
Oh, that's a big question for this technology. I think we're on the verge of a new era of AI. RLMs have the potential to revolutionize everything.
Everything.
From healthcare and finance to education and entertainment.
Wow.
And as we continue to research and develop this technology, we'll unlock even more incredible possibilities.
I can't wait to see what the future holds.
Me too. It's very exciting.
We'll be back in a moment to explore some practical examples of how RLMs are being used to solve real-world problems. Welcome back to the show.
We've covered a lot of ground so far, from like understanding how RLMs think
it's been
to exploring the tools and techniques that are used to build them.
It was quite a journey, but now I'm excited to see how all of this comes together in practical applications.
How are people actually using these RLMs to solve real-world problems?
Exactly.
I'm ready for some real-world examples.
Okay.
The blueprint we've been talking about actually provides like a step-by-step process.
It does.
For building an RLM, almost like a recipe.
It is kind of like a recipe. So can you walk me through it?
Absolutely. The first step is defining your reasoning scheme. Remember, that's where you choose the structure and the strategy for how the RLM will approach problem solving.
Right, like choosing between a chain, a tree, or a graph structure.
Exactly.
And then deciding on a strategy like MCTS.
You got it. And the best choices really depend on the specific task that you're trying to solve.
Right. It's got to be tailored.
Think of it like choosing the right tools for a project. If you're building a bookshelf, you'll need different tools than if you're painting a portrait.
I like that analogy. So if you're dealing with a problem that requires like exploring lots of different possibilities,
a
tree structure with MCPS might be a good choice.
It could be.
But if you're tackling a more straightforward,
Yeah.
linear task,
Mm-hmm.
a chain structure could be more efficient.
You got it. Once you've got your reasoning scheme in place,
Okay.
the next step is defining your operators.
Right. Those are the actions the RLM can perform.
Exactly. Yeah.
Generate, refine, and evaluate.
You got it. You need to carefully consider which operators are essential for the task at hand
Okay.
and how they'll be implemented.
Right. Because some of them might be more important than others.
Some operators might be neural networks,
Okay.
while others might be simpler rule-based algorithms.
So it's a combination of AI and traditional programming.
Precisely. The best approach often involves blending different techniques.
Interesting.
After you've defined your operators, the next critical step is figuring out the training details.
Right. That's where we teach those models how to make good decisions.
Exactly.
We talked about techniques like supervised fine-tuning and reinforcement learning.
You're right on track. The training process is what shapes the RLM's reasoning abilities.
Okay.
You need to select the right training data, choose the appropriate models, and fine-tune everything to achieve optimal performance.
Right.
And the blueprint provides valuable guidance on navigating these complexities.
This is starting to feel a lot less overwhelming. It's like, we've got this recipe,
Yeah.
and we're just following the steps.
I like that analogy. But remember, just like with any recipe,
Yeah.
there's room for creativity and experimentation.
Of course, you don't want to follow it exactly every time.
The blueprint isn't a rigid set of rules.
Right.
It's a flexible framework that can be adapted to different tasks and domains.
That's what makes this field so exciting.
I agree.
It's not just about following instructions. It's about understanding the principles
Right.
and using them to create something unique and innovative.
Absolutely. Now let's bring this all to life with a concrete example.
Okay, I like concrete examples.
Imagine you want to build an RLM that can generate different kinds of creative content.
Okay, creative content.
Like poems, code scripts, even musical pieces.
Wow.
You could start with a tree structure and use MCTS as your reasoning strategies,
Okay.
giving the RLM the freedom to explore various creative pathways.
So each branch of the tree represents a different creative direction the RLM could take.
Precisely. You would then need operators to generate new segments of content,
Okay.
refine those segments based on style guidelines, and evaluate the overall coherence and creativity of the output.
It's like having an AI brainstorming partner,
Yeah,
always coming up with new ideas
exactly.
and pushing the boundaries of creativity.
And to train the RLM,
Okay,
you'd expose it to a massive data set of different creative works,
got it.
teaching it to understand and emulate a wide range of styles and techniques.
So it's like teaching the RLM to be
Yeah,
a master of all creative trades.
exactly.
This example really highlights the power and versatility of the blueprint,
It does.
and it shows how we can use these seemingly complex concepts to create AI that can generate art music, even code.
It's mind-blowing, isn't it? And this is just one example.
Yeah.
There are countless other ways RLMs can be applied to solve real-world problems.
We started this deep dive feeling a little intimidated by RLMs.
I know it's a complex topic.
But now we're understanding how they work and even imagining the amazing things they can do.
It's been quite a journey.
It really has.
Sure.
But it feels like we've only just begun to explore the potential of this technology.
I agree.
What are some of the most exciting directions
Okay.
for future research and development
Yeah.
in the world of RLMs?
One area that holds immense promise is integrating RLMs with external knowledge sources.
External knowledge sources so they can access even more information.
Imagine an RLM that can not only tap into its internal knowledge,
Okay.
but also access and process information from the real world,
Okay.
like databases, websites, sensor data, you name it.
That would be revolutionary.
Yeah.
It would be like giving RLMs access to the entire internet.
Exactly. It would unlock incredible possibilities for problem-solving decision-making, even creativity.
That's amazing.
Another exciting area is the development of more human-like reasoning abilities in RLMs.
More human-like, you mean like they could think more like us?
While they're already impressive,
Yeah.
they still struggle with things like common sense reasoning,
Right.
emotional intelligence,
Right.
and understanding complex social dynamics.
So the goal is to create RLMs that are not just intelligent,
Yeah.
but also empathetic and socially aware.
It would be incredible.
RLMs that can truly understand and interact with the world in a human-like way.
That's the ultimate dream. It's a long road ahead.
Yeah.
But the research is moving in that direction. It's an incredibly exciting time to be working in this field.
Yeah, for sure.
Who knows what breakthroughs await us in the future?
It feels like we're standing on the cusp of a new era of AI.
It does.
And RLMs are leading the way. It's been an incredible deep dive.
It has.
And I hope our listeners are walking away with a sense of wonder and excitement.
Me too.
About the future of this groundbreaking technology.
It's been a pleasure exploring this fascinating world with you and our listeners.
It's been great having you on the show.
Thanks for having me.
Until next time, keep those brains buzzing.
I will, you too.
And that's a wrap on our deep dive into reasoning language models.
It's been fun.
We'll be back soon with another fascinating topic, ready to unpack even more mind-blowing ideas and innovations.
Can't wait.
Until then, stay curious.